The title of my paper is Computer Vision Aided Hotspot Creation in Virtual Environments. I'm the main author, and Dr. Bilal Nakhal from BAU is also another author, is the second author. So it's basically related to building virtual environments and automatically finding hotspots in these environments. I'm going to start introducing the topic, and then I'm going to move forward to the pipeline that we created the hotspots with, and show some experimental results related to our technique. And of course, I will be ready for having your questions. So at first, I want to start from the topic of this conference, which is the metaverse and hybrid metaverse. So basically, the metaverse offers a parallel universe that allows access to 3D virtual spaces. Of course, these 3D virtual spaces can be synthetic or coming from the real world. So it has direct and indirect effects on architecture, where architects can build synthetic virtual environments in this metaverse, and also they can reconstruct whatever they have in the real life in this metaverse. And of course, you've heard of a lot of architectural elements that are being incorporated in the metaverse, like supermarkets and buildings and these kind of things. Of course, to navigate the metaverse or to navigate the virtual environment, there are a lot of tools that the users can use so that they can move around the environment or interact with the environment in some sense. One example of these, of course, is the Oculus, for example, which allows this kind of navigation. We look at the metaverse in this paper as formed of a set of virtual environments. So we have a virtual environment which is imitated by or is created by a set of 360-degree images. These 360-degree images or panoramic images form a virtual environment in which we want to find some interesting locations in the scene so that the users that are navigating the scenes can interact with. And this is what we define as hotspots. So we have a 3D space, and we'll assume that this space is formed of 360 panoramic images. Of course, these images can be synthetic, but the technique for finding the hotspots can vary in some sense, depending on the data set that you train your images on. So we have these virtual hotspots that we want to find in the scene. These hotspots can be object hotspots, transition hotspots, or info hotspots. Of course, when we say a hotspot, it's a point of interest in the 360 image or in the panoramic images. You can interact with these object hotspots. For transition hotspots, you can move from one virtual environment to another. So basically, you are in a panoramic 360 view. Then when you navigate to another panoramic 360 view, it will be through these transition hotspots, in addition to some hotspots which can show some information, mainly for education purposes or some sense. Of course, this is some way of defining these hotspots or categorizing these hotspots, but of course, these categories can also be divided into further categories. So given this virtual environment, now we want to create the hotspots in the environment. How these hotspots are created currently, and this is one of the most important modules in the virtual environment to allow the navigation. The current approaches are manual. So basically, through the IDE, the creator of the virtual environments goes and finds some interesting locations on which he wants to add some information, or on which he wants to add some navigability. And basically, they are manually found in the scene. In our approach, what we want to do is we want to do it automatically. So we want to make use of computer vision techniques that are currently available, and basically try to automate this process so that to make the creation of hotspots in the scene become easier for the creator of the environment, and even for it to become smart in some sense. So you would be able to automatically allocate and identify areas and spots of interest in the virtual environment, and basically facilitate the development phase of the virtual environment for the creator of the environment. Of course, because it's a manual process, the creator might sometimes miss some points of interest or not have some information about it. So this automatic approach can help them identify these hotspots automatically. In the related work to our topic, so basically I divided the related work into categories related to how we deal with this problem. For the topic of hotspot creation, there is not a lot of work that is related to this topic. Basically, most papers that relate to the hotspot creation approach, they show how to add the hotspots and create them in the IDE, and how to show them visually within a virtual environment, but it doesn't deal with the automatic creation of these hotspots. There are some tools that allow to do this manual hotspot creation process. I also show related work related to the training data, of course, because we want to use computer vision techniques and basically some machine learning techniques incorporated in computer vision. We want to look at the data set that we want to use when visualizing the hotspots that we created, or when learning about how to create these hotspots. So there are different data sets related to training images to find interesting objects in the images. These data sets can range from 2D to 3D. I want to highlight the Sun 360 data set here because it's based on panoramic images, which are 360 images, which are mostly related to the topic of hotspot creation. In addition, related work to object detection. In the pipeline of our approach, we use object detection in order to find these interesting scenes. Of course, object detection is a very hot topic in computer vision community and image processing as well. It started basically in the early 2000s. And one of the most important techniques for object detection was using HOG features, or histogram of gradient features. And it developed until recently, it got more advanced, where deep networks were incorporated in the object detection modules. And now the state-of-the-art models for object detection are basically using deep networks. So this is the deep network that we incorporate. So this is basically the related work to our paper. As for the automatic hotspot creation approach that we use, we basically use this pipeline. So we start from, I want to go through the pipeline first, and then I'm going to give you details on each of these modules. So we first start from a 360 panoramic image. We have an image that is 360, or we can say panoramic. In some sense, it's 3D, but it is just a panoramic image where you can see the scene from different angles. Then we apply perspective projection to these images so that they become 2D. We can see them in a projective view. Then we apply segmentation to the 360 image and object detection to the 2D image. Then we use both the segmentations and the detection results in order to find the hotspots within the panoramic images, which are the interesting locations in the panoramic scene or in the virtual environment. So I'm going to go through each and every step of this pipeline. For the perspective projection step, we basically take the panoramic image and project it into perspective view, which is the view that you can see, that the user can see in the IDE when navigating the environment. In order to do this projection, we use an equirectangular projection where the projection model is formed by a multiplication of the tilt and roll matrices. So we form a matrix of the tilt and roll, which is related to the field of view of the navigator of the environment, in addition to the calibration matrix, which is also computed related to the field of view. And finally, we find a projection of the 360 image into perspective view. Of course, for each panoramic image, we will get different perspective views. For example, here you can see we create a collection of projected images. So we take different pan angles and different tilt angles, and we take these, sorry, there's a typo here. So the roll is ignored in panoramic images. So we take different pan angles and different tilt angles, and thus for one panoramic image, we get multiple, we can say P plus T perspective projection images. We use these together in order to find the detected objects in the scene. So now for the object detection module, so once we have perspective projected the images, we have a couple of images that we want to detect the object on. Each perspective image is input into a pre-trained deep network. The deep network that we use is the YOLO network. It's the current state-of-the-art network for object detection. Basically, this network applies a single convolutional deep neural network. It's a CNN network. It applies it to an input image by dividing the image into different regions. The output of this module will give us some interesting objects inside the scene or inside the projected images of the scene. So for example, here, you can see a perspective image from a scene, from a panoramic image, and we detected the chair, for example, and the sofa, and we detected from another angle the TV monitor. So you will have for the same panoramic images, for the same panoramic image, different angle, and in each angle you will find different objects that are related to the virtual environment. So this is the object detection module. As for the image segmentation, basically the segmentation, we use it to give us an overall understanding of the scene. We divide the input image into a set of segments, which gives a simple representation of the main areas that have similar color and texture. Of course, for the image segmentation as well, there are different techniques for segmentation. There are some deep networks that apply segmentation as well. We use k-means clustering technique because it's simple and efficient. Basically, the k-means clustering takes here we take the RGB colors of the images, the RGB color features, and then we cluster them into different clusters so that we can identify different groupings of semantic elements in the scene. So you can see here, this cluster would relate to a wall or a ceiling or a chair or a floor. And these semantic segmentations will help us identify interesting hotspot locations in the virtual environment. Now, once we have the segmentations and the object detections, we want to localize the hotspots. So we'll take the segmentations and the detections. The segmentations will help us get some view of the floor of the scene, the bottom area of the scene in which you can navigate the scene so that you can go from one place to another or from one virtual environment to another. Of course, adding door detection, if you detect doors as well, you can navigate through the floor and go to the door and move to another location. The objects that are detected also, I just want to mention that the objects, for example, for the same panoramic image that you projected into 2D images or perspective images, sometimes for the same object, you will get this object detected in multiple images. So in order to keep only one of these detections or one of these hotspots, we apply the concept of non-maximum suppression. So we have a score. The object detector module will give us a score for each object for overlapping objects or the object that is identified multiple times in the projected images. We take the detection that has the highest score by applying non-maximum suppression. Maximum, so you suppress all the non-maxima. You take only the maximum scored object and then you identify it as a hotspot. And eventually you get a sense of the hotspots that are available within the environment. As you can see here for this image, for example, you can see hotspots created on multiple chairs depending on the field of view of the navigator. So when the navigator is navigating the scene, he can see the hotspots that are available here, and then they can interact with the chair, for example, to sit on it as well. These are some results that we managed to find for some images. So this is an input image in an indoor scene. You can see a hotspot on the TV monitor, on the sofa, on different sofas as well. We also here managed to detect the chairs in an indoor scene. In addition, here we have a TV monitor and a sofa. Here also you have some sofas. And here even we can do it in outdoor scenes. Here we detected hotspots on cars, on people as well, if you want to interact with people in a virtual environment. Of course, the types of objects that we could detect depend on the pre-trained YOLO detector. Adding more objects to that pre-trained network will give us more hotspots in order to navigate. So these are some of the results that we had. So basically, we were able to create an automatic hotspot creation approach, which allows us to find hotspots in 3D virtual environments, especially that are panoramic environments. We use two main computer vision tools, which are object detection and scene segmentation. The candidate hotspots are automatically identified and can be within the virtual environment to be later used by either the navigator or the creator of the environment. Of course, this also helps the creator of the environment to find candidate hotspots, especially if you have, for example, repetitive objects that the creator might not identify or might not identify as important or might not be able to create. In addition, if you created, for example, some operation on one of these hotspots, you can take this operation and apply it on all similar hotspots in the scene because they belong to the same object type as well. based on our research, we found that this automatic hotspot creation has not been studied enough in the literature, and that this tool can be considered to be the first to handle such a problem. In the future, we could work on training the deep networks on 360 images instead of having the pre-trained 2D images network, and basically propose hotspots that can be incorporated with advanced tools in the virtual environments and incorporate them in the IDEs that the virtual environment creators can use automatically in their virtual touring websites. And of course, this will have a direct effect on the metaverse, of course, and on the understanding of the metaverse in relation to the users and the creators of these environments. So this is my presentation. Thank